Hello everyone. Today I'm going to show you how to build a complete DCC controller from some components that are readily available on the internet and with no soldering required. It consists of just two boards, so an L298 motor shield and a WeMos D1 R1 Arduino format board which contains an ESP12 chip. So the board that you want here is the D1R1, which is the obsolete version. There's a more recent version which is the D1R2. So look at the markings on this one. I think the R2 has a bigger logo here, but basically the D1 will do the job and it's obsolete, so therefore it tends to be cheaper on the internet. You also need a switch mode power supply that puts out 12 volts, and you'll need some wires to connect up to the track. So in this case I've just got a couple of crop clips on the end of some wire to wire between the two. The other thing you will need is a mobile phone or a tablet running Android, or alternatively running Apple. Now there is also an option to add local hardware controls, which I'll talk about in part 3, but I won't cover that at this point. So you need a phone, an Android phone or an Android tablet. Doesn't have to be a powerful one. If you've got children, you probably end up with quite a few of these obsolete devices. This one I think I picked up for 50 bucks online, and on it you will need to download an application called Engine Driver, which is available free of charge from the Play Store. I prefer the Android version because it's free and you get more features. There is a version called WiThrottle that's available on the iPad. That's a more basic version. There's a premium version for about $15. Both of those will work with this setup here. When it comes to wiring up the configuration, the first thing that we need to do is to cut a couple of jumpers on the back of the L298 motor shield. So those are these jumpers here. They're called the brake disable jumpers, and you just run a very sharp knife in between the solder pads to cut the very small link that currently exists between them. The reason that we need to do that is that these pins are also used for the I to C bus, which can drive additional hardware, and if we left them connected, then the signals on that bus would interfere with the DCC signals we're trying to put on the track and the system wouldn't work. So you just need to cut these two. Those are the only two that you need to cut. Then on the flip side of this board, what we also need to do then is to common together the A- and B- and A+ and B+ channels, because that will give us double the current capacity going to the track. This system only supports a single output, so you can drive your locos on the track. You can also use it as a programming track, but unlike other systems, it doesn't have a separate programming track output compared to the main output. So common these two together, and that will give us a total, I think, of up to 2 amps on this device. Also, it's a limitation of the D1R1 board, but this guy only has a single current sense input on it. So when these two are common together, it's only actually monitoring the current sense on the A channel, and the software compensates for that with a correction factor such that it's figuring out what the total current on the whole system is. And that current monitoring is used to trigger a safety trip if you have an overload. So the next thing to do is to program up the WeMos board. So you do this through a USB cable and using the Arduino IDE environment. I'll cover that in more detail in part 2 because people seem to run into issues trying to compile the software that I've provided. So I'll talk about specifically which libraries you need and how to compile it and how to load it onto this board. But once the software is loaded, You can actually test the Wi-Fi feature just literally like this with nothing else connected, just running it on the USB, and you should be able to see the DCC ESP SSID appear on your phone and actually connect to it. So that's one quick test you can do before you assemble the final hardware together. So when it comes to assembling the boards together after you've programmed the D1, you literally just stack one on top of the other through the pins. Before we do that, I'll just make a mention of how the unit is powered. Now, with this particular system, you only need a single power supply. So we have here 12 volts at 2 amps. And the reason you only need a single power supply is that the D1 board very conveniently has on it a buck converter that will step a voltage down to 5 volts, and then it has a further regulator that then takes that down to 3.3 volts, which is what's needed by the ESP chip. And the buck converter is very efficient and doesn't get very warm at all, and it can handle input voltages up to 18 volts. There is a connector called VIN that links the two boards together, and that will take 12 volts from the D1 board up to the L298 board. And so therefore you can just jack the 12 volts into the jack, the power will be carried up to the L298, and then it will drive the track. The limitation on that is about 1 amp, because that's typically what these header connectors can handle. Alternatively, if you wish to power the thing and run the system at say 2 amps, then it's advisable to get yourself one of these pigtail connectors, and then you would connect it to the markings here that are V in and ground. And in this case, the 2 amps stays on the L298 board, and a few hundred milliamps then flows back from V in through to the D1 board to power that board. So again, there's no soldering required if you use one of these guys. As an alternative to one of those pigtails, you could also use one of these guys, which is again a socket with a couple of terminal connectors on, and then you just use a piece of wire. So literally all we need to do now is just stack 2 boards together and then power it up. So I'm just going to jack the power into the jack socket there, and after a few moments the lights will come on. There they go, and that indicates now that the system is booted and it's putting a DCC signal on the track. Okay, so now we've got the system hooked up, powered up, and it's putting a signal onto the track. We've got a loco on the track here. What we need to do next is connect our phone, Wi-Fi settings, and find the SSID, which is this one here, DCC ESP, and you connect to that. So this is a local connection arrangement where the phone is talking directly to the WeMos board. You're not going through your home router. All we need to do then is fire up the engine driver application, and for this unit the default IP address is 192.168.61 and port 12090, so we'll just connect there. That'll connect through to the unit. You can see immediately that we've got connection and the power is on. There's a little green symbol there. You can toggle track power on and off by just pressing that button, so you can see that the power is coming on and off with the button. And the next thing to do would be to select a loco. Now the software can store up to 8 locos in its roster. I've got one defined here for the loco on the track, which is 464, and then we advance the throttle, you'll see the guy roll along. There he goes. So we can stop that, reverse it, again stop. And also if you have turnouts or points, then those can be controlled through the menu as well. So here I've got some defined. I've got a mainline, goods, shed, and a decoupler. Because the engine driver application doesn't directly support service mode to allow you to program your locomotives, I've provided some additional web-based pages which you can access through the web menu here in engine driver, and that will pull up these DCC ESP home pages. So the first one is basically a page that allows you to monitor the current draw on the track and to also set a trigger threshold So for example, at the moment it's set to a 1 amp trigger point. If the current on the track exceeds 1 amp, it's an overload condition and the power will trip and shut off. So you can change that here. You can also invoke this menu option to go to the Loco Roster. And so here I've got 4 locos defined. Loco 464 is grayed out currently because it's in use. It's connected to this very throttle. But you can add additional locos here or change them, modify their addresses, modify whether they use 128 speed steps or not, and name them as well. And anything you name here will then be reflected back in Engine Driver. So, so say for example we chose to rename Lucky and call it Cat instead. Then if we save that, then if we go back to the throttle and we were to select another engine here, you can see that that loco has been renamed Cat. So the roster is dynamically sent back to Engine Driver through this. Same thing applies to the turnouts. So I've got my turnouts defined here. I can add more, I can delete them here as well. It's also possible to do it in Engine Driver, but you can't actually name them in Engine Driver, so it's easier to do in this web page. Service mode, which is important for programming locos. So we need a means to sometimes program some of the configuration variables in our locos, and you can do it here. So what I'll demonstrate is I'll demonstrate reading back a CV value. So we'll just read the value of CV29. So I will ask it to read the CV. You should see this little loco chug along the track as it's sending current pulses back to the unit. And it's read back a value of 35. Now, it's not 100% reliable, but it seems to work pretty well. Sometimes if it doesn't read, it'll come back with a question mark. So you just ask it to read again. So here's an example where we asked it to read CV8 and it hasn't managed to read it successfully. You can just keep trying until it successfully pulls the number in. So at the moment it's still struggling with that CV for some reason. There you go, 36. This might be because the track is a bit dirty, because the system relies on trying to pick up current pulses every time the loco moves. You can also write to the loco here as well using the direct write method. The other important thing to note is that when you're on this page, it limits the current availability in the track to 250 milliamps, because service mode is also known as programming track and is really intended for when you've just installed a decoder in a loco and you're trying to check it out, and if you've miswired it, you don't want the system to be able to pump 2 amps into that because it might blow something up. So it'll limit the current to 250 milliamps and shut it off very quickly if there's a problem. So you really only use service mode in limited circumstances, and you can only program one loco at a time. If you have more than one loco present on the track when you use service mode, then both of them will end up picking up the same values, which you probably don't want. There is another programming mode known as programming on the main, and that's also supported here. I won't go into too much detail, but you basically would set the loco address, so you're now directly speaking to individual locos, which is why you can do it on the main line. So you single out a loco and say, hey, it's 464, I want to send it this CV setting, and you can either send it as a bit write or a byte write, depending on what you need, but you can't read any readings back through program on the main mode. You'd actually need another system called LocoNet, which this particular setup does not support. You can also access all of those web pages just through a browser like Chrome. Again, you know, it could be on your mobile, tablet or a PC. And so you just navigate to 192.168.61 index.htm and it'll pick up those same pages. So again, you know, you can access those pages, but it's more convenient to do it from within inside the Engine Driver application. I'll just talk about short circuit protection quickly. Quite a common scenario is that the loco runs over a set of points that are set against it. It'll create a short and you could potentially have a couple of amps throwing through your loco pickups and wiring, which in the worst case could actually melt or damage something. So it's important that the system's able to react quickly to current overloads and shut the power off. Ideally you want to set the threshold pretty low. By default the system is set at 1 amp. So, you know, to give you an example of what happens, I'm just going to use a sugar cube resistor here. It's 3.3 ohms, and that will simulate a short circuit on the track, and you can see that the Loco's power goes out, and the indicator here on the app indicates that the power's gone off. Okay, and you can reset the power here. You can see it's come back on. And similarly, if we were to go into web and look at the power, switch it back on. So at the moment it's saying 3 milliamps because there's nothing running on the track. If we short that out, you'll see that it's tripped, and in this case it's tripped at 1056 milliamps. So there you have it, a very simple DCC controller with just two boards from the internet and no soldering, and fully open source and loaded through the Arduino development environment.